job project that doing large scale refactoring for a customer for their legacy system, which I will talk about later. And all along the journey, I find I'm very passionate about AI. I'm not feeling it's robbing my job. I feel it's, I enjoy leading a group of agents to do the job for me. That's my personal take. And I also have previous SRE experience. I like tinkering things to make it better. So use AI, it helps me to tinker much faster. So that's about me. Now let's switch gear and have a look at the problem space. When I was assigned to that particular customer, they have a large code base of 3 gigabytes and 300, close to 300 git repos. Someone did ask 3 gigabytes, does it including .git? It does. So maybe roughly 2 gigabytes of the raw code and the scripts. And not only that, because of the number of repos, or if you prefer mono repos, it's the same 300 folders, but within that, there are more than 200 plus services. I don't know how the solution architect back then designed it, but it's not an easy one. And it's a legacy system, more than 10 years old. Everyone moved on from the development. Most people left the company. A few guys is still there, but they're working in different areas now. But funny enough, it's still very important to the business. They cannot just get rid of it. It's generating the revenue for them. So if it's done, or I heard if it's it was once done for a while, and the company even have to pay money to the customer for the compensation. So that's not good. So I and a few of my colleagues is coding to help them uplift the observability, to know how it fails, and how to track the failure, and how to make sure it works better. So that's background of the problem.
Was this largely one language or multiple?
Sorry?
One language or multiple languages?
For this one, it's one language. It's .NET 4.8. Pretty old. So this is our ultimate task. We want to know how the application fails. We want to know if it fails, how it fails, and how to prevent that. And there's some legacy monitorings on the system as back then, but it's monitoring, not observability. So one of the tasks is move away from the legacy monitoring to the modern observability. The tech stack is an open telemetry, which is chosen by the customer. So it's move away from monitoring to the observability and enhance the failure detection and the availability of the system. That's my task. So I always want to do something, and I actually did on this code base. When customers threw those close to 300 git repos to me, I just use a one-shot prompt saying, hey, Cloud, do me a favor. I'll move it to open telemetry. So it does work for a few repos. So Cloud and the Anthropic model is so smart. It's saying, hey, let me do the first repo. Okay, there's a code. I put the SDK instrumentation there. And then, hey, it looks good. Let's move on to the next repo. After 5, it says, I have done 5. Do you want to continue? And then I say, yes. And then it do another 2, and then say, hey, job done. I done 7. And the rest, I don't care anymore. Let's discount that laziness from the Anthropic model aside. It's just going to do repo by repo with some random, very far from useful contents there. So that's a reality. I guess most people have tried that one way or another. Why it doesn't work and what's missing here. Let's keep that in mind. Let's find out in the later part of the talk. So to deal with it, I decided to step back and think about how I would do it without AI. So I would probably first find out the SME and solution architect have a discussion, if they are still available. And ideally find out all the design docs. But this system is so old. It was designed back in the days of Link, and people use local laptop to store the design doc and share the doc with link with each other. There's no group, no team, no Skype, nothing. And pretty much it's all gone from as far as I can see. Maybe it's hiding somewhere, but it's not easy to find. But the people, there are still a few people there. I try to talk. They roughly not remember how the system works. It's IIS on EC2. There's a load balancer in front, and there are many, many modules. And that's as much as they remember. So I can...
software updates.
No one. No one is doing any maintenance. It's just routing there. Some people are doing some features, but yeah, I don't know how they operate. So I'll probably ask top 10 repos, like the infrastructure repo, the IIS building repo, and some of the key components, and see how it works. That's how I would do as a human. My memory can only allow me to work on 10 repos. Beyond that, that's too hard.
I mean, they did that. It was rebuild an option. Was there so many bugs? I didn't rebuild, but just get it working, just migrate it.
That's not an option. It's a huge system. It's but with AI, it's not necessary to rebuild. Let's make it better.
You do have it, so
Yeah.
it could be an option.
Yeah, but this customer choose to uplift it. So after I know what in Git repo to start with, I need to mentally rebuild the application architecture and the domain knowledge user stories, and then start working on the select repos to improve it gradually. As you can imagine, this is not a very efficient process. I would say if after 3 months, I can roughly know about the application and start contributing, that's a big win already, which customer agrees as well. That's without AI. So yeah, basically without AI, I want to migrate away from the legacy monitoring may be easy because I can use the grip to find out what's there and change it. But improving the observability will be very hard because I need to have the mental model of the application. So that's exactly why application was neglected for many, many years, because people lost the knowledge and cannot work on it. So how do we do it with AI then? So before I jump into that, the actually how it works, I want to make sure we are on the same page about large language model. I know some people use it a lot and more than I do now, and but there are still many people don't use it a lot. So let's set the foundation first. So the strength of the large language model as of now is its code comprehension is very good. It understands what you are writing, and it can generate code. It's pretty good, I would say, as long as you tell it to do the right thing. And the capability is growing every day. But some of the properties of large language model we always need to keep in mind is first, it's probabilistic. It's not deterministic. What does probabilistic means? That means if you run the same prompt on the same content for more than one time, I guarantee you it will be different. The output will be different. And secondly, it has a limited context window. On that, most model nowadays has 200,000 200,000, yeah. So some of the model has 1 million. That's definitely more than what I have in my context window, but it's still limited. You cannot shovel everything into it. You have to decide what information to trim, to select before shovel into it. Third, the large language model behavior, you cannot explain it. It's literally the frontier of the study of the large language model. So you can create a prompt, let it work and see how it behaves, and tweak it a little bit and see how it changes the output. Kind of. Yeah. And one last one is, I think the most important property is susceptible to error accumulation. This is linked to the biggest problem of the large language model, hallucination. Nowadays, I would say it's hallucinating maybe 5%, 95% correct. Better than I do, but still 5% there. That means if you design a very complex workflow with a lot of steps along the way, it's very important to pick out those 5% and make sure it's not fitting into the next step. A system of 95% correct after 10 steps is pretty much useless. You want it to be as close to 100% to fit in the next step so that a 10-step system is still functioning after 10 steps. So for this work, customer kindly enough provided a cloud code with Bedrock. It's basically free flow. It's pretty enjoyable. Another side of the large language model I want to set base is the patterns. Now we just talk about the large language model itself, but how we link it together is design patterns here. So a few ones I utilize a lot is first one is memory. Next meetup actually will be a deep dive on some of the memories. But memory is a pattern. That means you create some information, note it down, and use it for later. Second one is a planning pattern. That's pretty much the most used one, I would say. So you analyze something, create a plan first, and ask human for review. And then if it makes sense, let AI do the job, and you review the output again. That's if you have used code or similar tools, there's a plan and act mode. That's exactly for the plan, review, act, review purpose. The reflection is like telling the kids to check the homework. So for example, I ask AI to create a sequence diagram in Mermaid, and in the reflection, I ask it to check, hey, is it actually a sequence diagram? Or is it actually a mermaid diagram? Don't create something I don't want. So AI will first do the job and then later check if it has done the correct job. That's a reflection. Routing and fan out is pretty straightforward. It's very similar to the messaging ones. I will show it later. I would recommend a book, Agentic Design Patterns. I have read quite a few books about large language model patterns. I have recommended this book to my colleagues, and generally well received. Why? It's only 400 pages. Others, 1,000 pages. And it's by Antonio Gulli from the Google, I think the leader of their AI team. And that means it's probably correct. And it's focusing on the patterns rather than implementation. So nowadays, I heard a lot of debate of agentic is gone, use a skill. But even with a skill, you still need these design patterns. So it's just applying differently. Otherwise, you will find the AI creating the stuff you don't want very quickly. So that's some basic foundation of the large language model and the design patterns. Let's first, I changed the order a little bit. First, let's go through the demo and see how it works. And then let's see the behind the scene, how I summarize this workflow. So as much as I wish to show you the actual 3 GB code, that's probably fastest way to get rid of my job. So I decide to use another very similar application, very chaotic, to show you, which is an astronomy shop. This is an open telemetry demo. So let me show. First, let me quickly show how the app. This is its how do I say, document page. One thing to keep in mind is the demo team tried their best to make it as messy as possible. So it's an online shop, and you can see accounting writing .NET, currency service writing in C++. Nowadays, who use C++ to write an online service? And you can see different services using all the exotic languages. And I only know Python and the .NET a little bit. Other languages, almost none. So this is a good example to test the large language model because I genuinely don't know most of the languages here. So how the hotel shops looks like, this is running locally on my laptop. So I'll give you a feeling. So go shopping, add a refactor telescope. I always want one. And go to this is in the shopping cart. And I place order. The order is placed. Then continue shopping. In the front end, it's pretty much simple. But in the back end, it's a lot of services. So now I want to do some analysis and uplift it. Now this prompt is very similar to what I actually used for the customer. Of course, it's removed all the customer information, proprietary information, and etc. But these are the skeletons of the prompt. So the first step is I want, in most organizations, the OpenTelemetry setup is in a separate Git repo. What I want is analysis the Git OpenTelemetry setup and get the information of how the endpoint, how the connectivity, and how to get there. What's the requirement of sending the data there, such as dimensioning, labeling, this kind of stuff. So I use this prompt. But because this is a demo, the OpenTelemetry is already set up. So here is what is created. So it can draw an OpenTelemetry diagram for you. And you can see the input is on the gRPC 4317, HTTP 4318, which is standard OpenTelemetry port. And also all the backend services they have, like, where is it? Yeah, Jaeger, OpenSearch, Prometheus, Grafana, it's all here. So with a simple prompt, I understand the OpenTelemetry setup in the organization. And this is going to be part of the memory that's going to be fit for the next step, designing the OpenTelemetry setup for the application. So this is outside the application. And let's go back to the application and have a look at analyze the system. So this prompt actually leverage the Cloud Code Explore sub-agent, which will quickly read through multiple folders and give you a quick context. So I ask it to read the source folder containing all the close to 300 repos, and then output an application overview. In the cloud, if anyone use cloud, this will be the cloud memory, cloud MD. But I'm not using cloud to create a demo. So, but this is still a memory file. It's just a different name. So in the first one, use a cloud the discovery sub agent to go through system overview, business purpose, technology stack, repository, inventory, how they group together, and finally system architecture and component architecture. Let's see. I give a look at the output. Yep. So it gives an overview. Assuming you have zero knowledge, now AI tells you Astronomy Shop is a microservice-based e-commerce platform. It business purpose, the key one is product browsing, shopping cart, checkout. And the tech stack, there's so many of them. And for each component, it's a different one. And the endpoints, front end, endpoints, etc.
Once you see this output from LLM, I assume you trust it only 95%. Right?
Yeah.
With the rest? How do you find it now is 5%?
This is where that's a good question. So what I notice is when you talk to an SME, if you bring a blank paper, they will stare at you and say, "I forgot." But now you have 95% there. You can go there, ask SME to review. Hey, is this correct? Is that correct? So they will likely give you more information. I tried a lot with this approach. Generally, if they ask SME yes/no question, they can remember. If they ask draw a diagram like this, they will say, "I forgot." So that's how I use it. Now, does it answer your question directly? No, because they could make more than 5% error.
Mm-hmm.
But this is a good starting point of discussion, and we can always tweak it.
Better than nothing, right?
Yeah. So the point is, this is a starting point. We have something to review, and if we find more information to say, "Hey, there's something wrong," we can always tweak it, and go back here and start again.
You said this is something to review. So what's your review? You mean like, what do you mean by that? Are you actually hands-on review, or you writing some tests?
It's a human in the loop review.
Yeah.
So for this kind of document, it's a human in the loop review.
Who's done this review?
Together with SME, application SME and me. Okay. So for this architecture, let's go back to the architecture diagram. You can see I didn't create this diagram nice enough for demo because I should tell the model to create a vertical diagram, not a horizontal one by default. But anyway, the input is to the Envoy proxy because it's a local demo as an API gateway. And it goes to the front end Next.js, and then all the product services check out different services. So it's pretty much a 3-tier application. And in the back, it also tells you how the current OpenTelemetry set up. Now, in the first pass, it gives you a very rough the product flow. So how each component interact with each other, and for the checkout flow as well, observability data flow, etc. And what else? Yep. That's pretty much on the first pass, the most important information you want to know. Application purpose, most importantly, business domain, and architecture diagram, infra diagram, and etc.
There's no unit tests, right?
This is also the discovery phase. This is not an implement phase.
Did they have any unit tests?
Let's go through that later. This is only the first step. The second step, the 11 steps. So next one is build application domain. So I ask the AI to, based on now I don't need to ask AI to read all the codes because I have an application overview. It becomes a memory of the system. I can just ask AI to reference the memory and read the code only necessary, and then create a domain-driven design and diagram. So this is not actually designing, but reverse engineering from the code and the application overview, how the domain looks like. I'm not DDD expert, but you can see the AI can create core domains, subdomains, ubiquitous languages, boundary contexts, all from the memory and the code itself. So that's pretty interesting and powerful, and it's especially helpful to let me start a conversation with a business owner.
Was it already domain-driven design?
I
would imagine it would be if it was.
So this application may be domain-driven design, maybe not, but we can always look into how should describe the application with DDD. This is how to do that. So next step is actually one of the critical steps for a very large repo. I want to categorize the Git repos. So even I'm talking about improving observability and moving away from legacy monitoring. Even with AI, I'm not going to do on all the 300 repos. I need to trim it down significantly. But how to trim it down? So in this demo, because this is only a demo, the information is a bit loose. So I ask if the repo or the application component already has OpenTelemetry or not, put it in a CSV file. So, yep. Is this the one? No. Okay. Yep, this is the one. So I can see there are a few components do not have OpenTelemetry enabled, particularly the messaging system, the Kafka is not there. Other components, because it's demo, it's already have OpenTelemetry. But in the real life example, out of close to 300, maybe only 10 repos have monitoring enabled. Others are just running freely. So now I can targeting those 10 repos for the monitoring uplift. So this is a critical step to categorize it and reduce the workload for next step a lot. Now, The next one is the endpoint discovery. This is actually one of the most impressive step in the actual work, but not here. It's very hard to demo on the demo app. So the actual system I worked actually has 1,200 endpoints, like API endpoints talking to each other. That's a huge number. Luckily, that number is still within the context window. So what I did is ask AI to find out all those 1,200 endpoints for me and summarize it into a CSV. So this is how it looks like. The connecting method, the API endpoint, public facing, and what repo and application it is, etc. So in this demo app, there are around 62 of them, but in the real life, it's 1,200 of them. So that, again, the purpose here is trim down the information. I don't want to fit in the entire application, the entire code for analysis. I want it to be very targeted. And the target here for an API-driven system is the API itself. So list out all the API and then fit into the next step. The next step is identify the critical path. So for a system, there are many user flows, many personas. But again, I want to focusing on the top 10 of them. So now I have the information of application overview, endpoints, and the summary of the endpoints. I want the system to use the API endpoint to tell me, based on the common sense, what are the most important part of this application.
When you say common sense, whose common sense is that?
The pre-trained knowledge of large language model. So because it can read the endpoint and see, okay, based on the nature of business, it's probably someone did something similar, and using the same domain knowledge of that area, for example, financial service, to help with deciding if your business is in financial service, how do you prioritize that? So I mean the pre-trained knowledge. So for example, in this case, it's a critical user path analysis. Now this is astronomy shop. So the suggestion is with zero input and suggestion. The large language model think the checkout and payment is most important one, which I tend to agree. And the product browsing is the second one. Why it's important? Because why getting this information is important. Now I can get top 3 user flow out and decide how I should improve the system. So it also tells you why it's important. This diagram has some bug. Let's go to the next one. The products browser, why it's a funnel path and it gives you how the system interact with each other. So I can check with check with SME if the understanding of the system by the AI is correct. If not, how to change that. And also it tells how many application services endpoints is touching. And with the sequence diagram, we can see which Git repo or folder we should touch. So again, it's trimming down the information. So now we have the endpoints, now the critical user path, which is the most important part of the business. We go to the next step. Because we have enough information of analysis, we want to improve the observability now. So before that, this another intermediate step is with application overview and the critical user path. I want the AI to design the SLO, service level objective, for me. Critical. So the first is some SLO design principle, and for the checkout and the payment, the AI suggests it's a most important part of the business, and because it's checkout, probably customer can tolerate waiting a little bit, but do not make it fail. So it's very high availability, but the latency can be a little bit more tolerate. On the other side, the product browsing, its availability could be a little bit lower, but the responsiveness must be very high because people will run away if it does not provide the response fast enough. So AI has this general knowledge from pre-trained data, and it can definitely apply to your business case. Again, this is still zero input from me prompting what's important or not. It's only based on the pre-trained common knowledge from the AI. So once SLO is designed, I want to create a synthetic test. So the next one is canary design. So for each, this is a prompt. For each, based on the critical user path analysis and the service level objective we just defined, we want to create a canary synthetic test and the dashboard. So I ask it to use a SLO and set up the open telemetry, and the dashboard should be in the Grafana. And let's run that and see the plan. So yeah, so the plan is to create a exporter and then send the data out. It's a black box exporter and send it to the Grafana all the way. And for this one, it's a pretty lengthy how to set up the code, etc. But let's see how the output looks like. So this is a synthetic test set up by the AI. For each critical user path, it tells you if it's up, down, or not. Grafana is used to be pretty time consuming to create, but now with a prompt, you can create a dashboard yourself. And for each of the critical user paths, you can also check the availability. Now you can see some data missing because I put the laptop in the sleeping. But you can see it's tracking the application availability and latency pretty well. And there are a few services done. AI is not perfect. When it's creating the synthetic test script, there are bound to be some errors. But I kept there because it can show you the up and down. It's actually working. The other part is this is improving the synthetic monitoring, which is outside monitoring. We also want to improve the traceability of the application. So next step is set up the SDK instrumentation. So again, based on the service level objective and the critical user path analysis and application overview, I ask AI to review how to improve the observability and then create the coding plan to provide more information for me to troubleshooting the application. Critical implementation plan. So here it gives a plan, a lot of information, but to make it simple. So let me go down. Where is it? Yeah, here. So for this example, for API, it also adds in the tracing, it adds the span of API user ID, order ID, and the order amount, etc. So previously in a tracing environment, we can know if a user, if we can know there is a transaction, but it's very hard to debug if it's got error because it's very hard to link it to a particular user. And AI identifies that and suggests that the user ID and order ID be added into the label of the span. And that's inside the code. For example, we go for the, in the accounting. So for the order, yeah, where is it? I have the order, what's the span? ID. So for example, in this consumer accounting code, it's smart enough to add the app order ID inside the span so that I can track it. So let's go to the Yager and have a look in the accounting service. Let's find the trees. So this is a complete demo. So there's user checkout created by the load generator. Let's just use that. Now, without this code uplift, we can know there's a long chain of the actions happen, but we cannot, it's not easy to link to the particular user. But now let's add here. So for example, we take a span, we can see the app order ID and the user ID is here. So that if we know there's a issue with a transaction, we can look back into the user and see what's wrong with the data or what's wrong with the interaction. So this is based on the AI suggestion. So imagine now look back, what if you tell the cloud code just to improve the open telemetry observability? Will it be able to do this? Probably not, because gradually we build more and more context, more and more information, understanding the system ourselves, let the cloud, let the AI know the context of the information gradually, so that it has more information to do the correct and productive action for you. So that's the demo. Let's go back to the presentation. So let's put that demo in mind. So the approach is analysis the system first, distill, which is find out the most important information. Triage is to decide what information you need to process, what information is not important. We can ignore it. And then finally, uplift the most important user path, which is most important of the business, and also migrate away from the legacy monitoring. So let's put it together. This is the actual diagram, the actual workflow. I will show it with redacted information. Yeah. So this is how it looks like. Now, I need to remove some information because I don't want to expose who he is. So in reality, it's 277 repos. And the first step is doing an analysis of the system, building the memory, together with Open Telemetry Gateway information, so that we know how to set up the Open Telemetry Gateway. And the next, categorize the Git repos, because it is IIS on Windows EC2 application. We categorize it into the AMI, infrastructure as code and application, which will be used later. And then we do the endpoint discovery, find out all the 1,200 endpoints, identify most important part of the business, and then design the service level objective for the most important part, and then create a canary dashboard, synthetic test and dashboard, and SDK instrumentation, and implement that. The demo is about the top part, which is analysis the system and uplift it. There's another part is move away from the legacy monitoring. So in the why it stopped working? Well, why it's not zooming out anymore? No. Ask AI. Maybe I'll just, yeah. So remember, I categorized the repos. Only maybe 15 out of them, out of the 300, actually has a monitoring setup. So for the legacy monitoring, then only for those 15 repos, I need to go and find out how it's set up and create a code change plan and migrate to the Open Telemetry. And together, I also put in the knowledge of the AMI building from the Golden Image team, and help to set up the auto instrumentation on the IIS. And also, there's another third path in this application. For the critical user path, the most important part of the business, not only I designed the SLO and implement the synthetic test dashboard and SDK instrumentation, there is also a skill to check all the security gaps. So the security gaps, what the organization care about, is set up as a reference and feeding and checking the code and find out all the issues and document it and raise a PR to rectify that. That's the entire system, how it looks like. So initially I was thinking for 300 repos, that's very hard, but by the end it actually worked and the customer accepted it. So that's a pretty big one.
Who
But
reviewed the PLs at the end?
it's a customer themselves.
Right.
Yeah. So there are 2 more slides before release everyone to pizza again. So take away. A functioning code has an entire domain knowledge of the business. This is a part I talk to people a lot. So previously, we want to have the knowledge first before touch the code. But nowadays, a working code has everything you want. It's just how you prompt it to give the information for you. On the other side, there are many other informations hidden in the code. A good example I always talk to people is how you deal with data pollution. Because in a production system, your code works perfectly, pass all the unit test, UAT test, integration test, go to production, boom. Why? Because there's a wrong data there. But in a large data, it's very hard to find out. So rather than comb through the data like previous I do, so now I just tell the AI, hey, read this code. This is understand the data structure. Now, after you understand, create a tool to go through the data, find out the pollution based on the error message. So I tried it twice. It works very well and surprised the business because they used to spend weeks to find out the data pollution. Now it's literally hours. So similar to wipe debugging, but wipe debugging is pretty common nowadays, but wipe data pollution cleanup is something I do a lot and surprise people. And always think about what information to feed into the AI. So this AI is very knowledgeable, but very dumb. So you need to give it exact information that is relevant to its task so that it knows what to do and how to use the correct information to help you out. So always think about the hidden information in the code, how to extract it, and how to feed AI with useful information. Now, last slide, let's go back to why the one-shot magic bullet didn't work. Because the dry side summarize is pretty wrong. So it's not specified enough what's the uplift. You didn't tell it. What's the context? Why? What do you want it to be? And how to improve it? And also on the OTel specific, do you want automatic auto instrumentation or SDK instrumentation? And do you want trace metrics logs? What's the success criteria? And how do you want it to be delivered? These are all the informations you need to fill into the AI to make it do the job for you. Okay, that's the end. Thank you. Questions?
I was going to ask you this question. So obviously, when you said uplift, it's based. So it's like you said in the end. So when you ask to uplift the code, and you didn't ask him to rebuild it. So again, so objective is not defined well.
Yeah.
So it looks like you used OpenTelemetry to reverse engineer what you had. But again, what's the end result of uplifting?
So here the customers ask is a more stable system. So this is a context.
How do you define stability then?
Less incident, more knowledge into the yeah.
It's faster. It's more.
It's very easy to give any kind of result when the objective is not defined. Like,
So
uplift.
you define it. It's the key point. You define it, and how to define it if you have knowledge.
Base in line of code that reduce stability. What's your measurement? What's your number that you can? I'll say if I pay money to uplift my system and uplift is not defined well what it is.
Yeah.
So how do you justify what you've done? What exactly?
This is a little bit out of the AI scope. It's more about the business value justification. Yes, you are right. So it's you can use AI to draft a proposal, for example, reduce the number of incidents, save you how much money, and this kind of template AI is very good to generate for the business case. You can generate a business case.
For the customer who doesn't really know what they want, who comes here with very generic, open-ended questions.
Yeah, you couldn't give an option. You could have said upgrade, and with no refactor, no domain-driven design, or we will do the thing. You just don't, and that's what I would do.
Yeah.
I would do it under the hood. I would tell them. I would go ahead and rebuild it.
Question?
Is the code still .NET 4.8?
Yes, unfortunately, it will be 4.8.
I'll never attract any developers to be able to work on it.
That will be 4.8 forever.
Yeah, I'll go with
Is
it.
Sorry, I can't hear.
Sorry,
you.
one at a time.
Could they use Claude Code to add, say, additional functionality to it?
Yeah, definitely. So again, they need to know where to add, what to add, how to test that. This is where they can use AI. Yeah, definitely. They're actually developing features on it still, but it's on certain modules only. It's not an entire uplift. So the whole system is a little bit full of weed, but they're still working on it.
In .NET, you've got aspect-oriented programming, so you didn't do that. The other frameworks don't support that. You could have done that with any IT. You don't need
Maybe, yeah. So a question? Yeah.
How do you ensure, like, when you use AI, how do you ensure that client details are like remain confidential, or do you have like different frameworks for that?
This is a good question. So there's a separate work on this customer on the AI governance, which is a lot nowadays. So for this customer, they decide they use Bedrock. So even I use Cloud Code, it's not go to the Anthropic API directly, it's go to the Bedrock. So they trust Bedrock a little bit more, and it's like a gap and gap compliance with AI. So that's a big topic of AI compliance. There's generally a program which Mantel does it as well, but it's audit, review, and build the boundary.
Still is the boundary of Australia all the time.
Yeah.
Goes back to the US.
Yeah.
Local.
Well, as US charges 7 times the price. No, I don't have it. 7 times.
So I guess this slide tells me that the objective wasn't really fulfilled because the input wasn't well defined, right? So his uplift doesn't really define any objective.
There's also some slides. The uplift here is not uplifting the whole.
So-
So, but it's just like adding telemetry to my project. It's not uplifting. It's just like,
Yeah, that's great.
I mean,
Yeah.
what's your
so as an engineer, I appreciate clarity. So tell me what is doing.
All right, maybe have a chat afterwards.
Yeah.
And we move on to other questions.
When you say I added observability, it sounds exactly clear what it does. But when you say I uplifted my code, it doesn't sound clear at all.
There's one more
We had a
question.
chat over more beer and pizza afterwards. But other different questions?
Yeah, I saw one.
Andrew?
My question is the beginning of the question. What's your actual workflow? Like, do you open up Claude desktop, or you sit in the CLI, or you just have a VS Code extension? And then when you move from one stage to another, do you start from scratch using the memory from Kubernetes, or do you try to give it a compact version of what you had before?
So it's a cloud CLI. I use a skill, but I directly prompt the skill. And between each run, I try to remove the context to give it a clean context. I call it, compared to other people, I use cloud more like a launching, but that's different way of doing things. So this talk, I'm more focusing on the principles and the guidelines, how to use it. This demo is not even created on the cloud code. It's created on the Anthropic model directly, because my company does not offer cloud code, but the same principle of doing things still apply.
I just don't want once you spend on tokens for that kind of refactoring, especially if you talk to Bedrock, which is like Amazon version of hosting of
Yeah.
like 3-digit, 4-digit, 5.
No, it's entire project costs $400 on the AI. Yeah, that's cheaper than I do.
That's cheaper than 1 day of consultant time
Yeah.
by a long way, yes.
1 day.
Yes, much cheaper. It's like maybe an hour of a lawyer, yes.
question?
Yeah, so some really detailed prompts that something I really struggle with is trying to explain what I expect the agent to go out to. How do you iterate new prompts? Like, do you like what you typically start with? Any tips for like writing a good prompt?
That's a good question. My like I have zero .NET background. All these prompt, once it's touched the .NET specific, I use AI to create prompt. So I tell AI what I want to do and how to do that. For example, I can't show the actual customer prompt, but for that endpoint discovery, apparently it's in the cloud code, it runs the Python code. So what I do is tell AI, hey, this is a large code. I want you to find out all the endpoints for me. So AI create a prompt that's actually use a rip grip, which I never used before, and most people don't even know about it. And then it's create a prompt to install the rip grip on the local, find out all the API and the controllers, and make it a Python script, run it, dump out all the 1,200 endpoints to a CSV for the next step. But to answer your question, I think if you have some confusion, doubt, area you're not familiar with, use AI to create prompt and run that prompt. That's a good starting point.
You could use a knowledge graph to actually put all the code into the knowledge graph. That's what I've done for my legacy systems.
Yeah.
So then you won't get the confusion cut down. Yeah. We'll try that next time.
Yeah. That's a question. Yeah.
More questions? Yeah.
So, you mentioned during your presentation was about reviewing the PRs. So you said that the customers review the PR.
Yeah.
So are you planning to sort of optimize the architecture and saying that the PR is getting reviewed by the LLMs rather than the customers in the future?
This is a good question. So actually they have LLM review PR. It's just finally human has to review it. Because if you ask AI to create, AI to review, you can see where it goes. But it's definitely those syntax errors and the small errors, AI can find it out pretty straightforward. But it's the logic and the semantic information that human has to be the final approval.
Security, not for the business logic. So they should be able to, those guys should be able to know that. They just go through the list of security vulnerabilities. But they're not going to, that's not done by the business guys.
Other questions? We exhausted the questions. All right, I'll give you one question.
Yeah.
So did you have like a closing the loop type stuff where you had like the AI check back on the Grafana and see if it was working yet and then fix up its canaries and that sort of thing in a loop?
Not directly in this project because it needs extra information like MCP server checking information. But it's back to the reflection model. As long as you feedback how it works to the AI, for example, error log feeding, it can definitely do the debugging and the troubleshooting for you. So feeding information, AI do the job for you.
You could give it to another model to have a look at.
Yeah,
Well,
exactly.
All right, so if no more questions, I'll ask you guys some questions. Oh, well, let's have an applause though. Thank you very much, Yao. That really has some mind-opening points there, and certainly a lot of new things to take on board. I think for most people, certainly for me as well, to manage such a huge code base in this way, and also add across so many different areas, and the way you filtered the information down as well to keep the. Anyway, I shouldn't say that because it's going to be the question. So actually, so first question, so this is for one JetBrains license, right? What are two of the patterns that Yao mentioned at the start? And I think they're probably in that book as well, but what are two LLM patterns? Yep, at the back.
Memory reflection.
Memory reflection, you got it. I think I gave you a license last time, did I? No? Fine, that's fine, you win. You win, all right. And the next one, which I was kind of just stopped myself before giving away the complete answer, Yao can correct me if I'm wrong, but like, why were there so many stages, right? What was the point of having so many different
To
documents?
validate, and we make sure you're carrying down all the main core of the system properly. I mean, like.
My text different, but maybe I'm wrong.
Asking a different way, what's a property of the LLM that we need multiple stage to deal with?
Yeah. True. But
It's probabilistic.
Losing the 95% complexity.
Limited context.
that's what I was fishing for, but we've had a few answers, so I think Yao gets to choose. Who do you think
Maybe
was the best?
one more.
One more? We haven't got the right answer, so keep going.
I think you guys are right.
I thought you were right, but let's keep going.
But it's also parallel connections.
Maybe trying to narrow down into one single task.
Too many features.
Wait, one thing, one person at a time. Andrew, you go, and then
Trying to say that maybe try to narrow the context to simple tasks so you can deal with that simple task before you come to another one which depends on the vision.
That's
are you hear
that's
all the answers, or are you happy with?
that's actually one of the answers. So there are multiple aspects of it. Context window is definitely one, and hallucination is another one.
Yeah.
So yeah, either of it will work. But you mentioned the context window, and I think someone mentioned context window before, right?
Yeah.
I want one.
Yeah. So yeah, I think that's a correct.
You want
I
to
just
say-
wanted to say, even
Yeah.
if I'm not winning anything, I think you said earlier that it's like non-deterministic, right?
Yeah.
So the AI will choose different paths.
Mm.
So this is like a system to make it.
But non-deterministic does not mean error. That's a difference.
Yeah.
So that's a little bit different. So it can give the correct answer in different way.
Yeah.
So it's mostly hallucination and context window.
Yeah, but having the multiple parts means that you're actually helping it to narrow it down to the correct answer.
Yeah. Okay.
All right. So, I don't know. That one's pretty hard to award the prize on.
No, it's non-deterministic.
It's a non-deterministic one.
Give an example.
Non-deterministic question.
But I have to think quickly because I only had 2 questions.
Yeah, question.
Oh, maybe. Oh, yeah. So, all right.
Deterministic for the error accumulation.
Yep. Yep.
We don't have that many deadline.
Yeah, so-
you only get 2 a month.
Yeah. All right. So one more question. So we've been talking about like this error accumulation. So what did Yao do to stop this error accumulating?
Set the context.
Now, what's a particular pattern used to deal with it?
Yeah. What did he do? I mean, that's kind of it, but
He looked at the results and checked it wasn't the same. Human loop.
Yes, exactly.
and who did he ask?
The people who are paying him money.
All right. Again, I think go to his subject matter experts, but yes, they were the ones paying him the money, so they were the experts by definition. Fair enough. All right. I think you win.
Oh, yeah.
Come for another license afterwards.
Okay.
All right.
I'll leave it to you.
Yes. Thank you again. Yeah, that was really good.
Thank you.